beginning came the creation. Time, space, matter, and energy were born. The early stars were formed. When their fuel was used up, the ancient stars died, some violently, leaving vast clouds of interstellar gas and dust. One of these clouds lay dark, cold, and silent for a very long time. Then, over 4.5 billion years ago, it began to collapse, perhaps triggered by the explosion of a nearby star. The cloud was pulled inward by its own gravity into a flat, spinning disk. At the center, a star began to form. From the leftover matter, planets were taking shape. Finally, the new star flared into life. The miracle of creation had begun anew. Now, 4.5 billion years later, a new miracle has evolved. Intelligent life, reaching out beyond the planet of its birth. In this golden age of discovery, we have seen worlds of infinite wonder. This is the story of these worlds and the star that rules their lives. This is the story of our solar system. Our solar system is no more than a tiny speck in the cosmos. The universe contains countless billions of galaxies, and our galaxy alone has more than 100 billion stars. They range from hot white dwarfs to cool red giants. Ours is an average star, yellow, stable, and long-lasting. The sun is an immense ball of gas, a seething furnace of hellish fury more than 100 times larger in diameter than the Earth. The sun is powered by a nuclear reaction deep in its center. Under tremendous heat and pressure, hydrogen is transformed into helium, and matter is converted into energy. During a full eclipse of the sun, we are awed by this overpowering force in our lives that we so often take for granted. Slowly, the sun is covered by the passing moon. Finally, all that remains is a rare spectacle, the sun's glowing corona, only visible during a full eclipse. The sun's outer layers are battered by twisting, turning magnetic fields that are constantly in a state of motion, as this huge ball of gas rotates every 25 days. Mysterious sunspots are evidence of these powerful magnetic forces. And so are the awesome solar flares that can equal the power of 1 billion hydrogen bombs. They often tower dozens of times larger than the Earth. The sun's outer envelope, the corona, is riddled with holes, seen here as dark areas. From them, a steady stream of subatomic particles blows throughout the solar system and beyond. We call it the solar wind. Particles from the solar flares and wind can strike our upper atmosphere, setting off a spectacular light show called the aurora borealis, or northern lights. For us, the sun is a kindly giant. It warms our world just enough for life to take place. Plants convert sunlight into usable energy. It's the very foundation of the food chain for all living things. On the other hostile alien worlds, we would perish instantly without special protection. But they are also children of the sun, to be treasured for their revelations about the mysteries of nature. As the solar cloud began to cool, lighter elements formed the mighty gas giants of the outer solar system: Jupiter, Saturn, Uranus, and Neptune. But closer in, higher temperatures and pressure created the dense rocky planets: Mercury, Venus, Earth, and Mars. In 1971, Mariner 10 gave us our first close-up look at Mercury, the nearest planet to the Sun. We found a desolate, battered world, pockmarked with meteor craters, a testament to the violence of the early solar system. Our rocky planets and moons were built up by collisions like these, as small pieces of matter came together. After the planets formed, the early bombardment continued. Mariner 10 showed us a Mercury that looked much like the Moon. This was our first proof that the Moon was not a special case. A massive rain of rocks and debris took place throughout the early solar system. We have since found more proof: impact craters on Venus, on Mars, and on most of the moons of the outer planets. Here was a primal force that helped to shape our solar system. Today, the bombardment is still underway at a much lower rate, as comets and asteroids occasionally strike our worlds and moons. "1994 brought the most powerful collisions in recorded history, as fragments of a broken comet smashed into Jupiter's atmosphere at 135,000 miles an hour. It was the cosmic event of a lifetime. 2 years earlier, the comet Shoemaker-Levy 9 was torn apart by Jupiter's gravity, leaving 21 fragments, the largest up to 3 miles across. They would strike Jupiter one after another for 6 straight days. The collisions would not be visible from Earth, but minutes later, Jupiter's rotation would bring each impact site into view. The Galileo spacecraft is our only witness to the visible light explosion of a comet fragment colliding with Jupiter's atmosphere. But the Hubble Space Telescope revealed a more dramatic sight: huge fireballs rising above the limb of the giant planet up to 1,200 miles high. A fireball would blossom a few minutes after every large impact. Then, minutes later, it would collapse into a flat cloud of solid particles as it cooled from thousands of degrees Fahrenheit to 350 below zero. Then came the most astounding sight of all. In the wake of these mighty collisions, gigantic dark scars were visible in Jupiter's atmosphere. Fragment G was one of the largest. It left Jupiter with a black eye, twice the size of Earth. By week's end, Jupiter was ringed with bruises. This image shows 8 crash sites, some on top of each other. The dark violet-brown markings were a big surprise. They may be rock and dust from the comet fragments. Earthbound telescopes picked up the heat of the collisions with infrared light. Traveling at enormous speeds, the particles released up to 100,000 times more energy than the largest nuclear bomb, as they plunged 60 miles into Jupiter's atmosphere. And here is an amazing sequence of infrared pictures. 2 flashes from incoming fragment R as it strikes on top of a previous impact site. 8 minutes later, a fireball erupts into view. This 30-minute sequence has been compressed into 30 seconds. The dark scars soon faded away, but scientists will be studying this event for years to come as they try to learn more about the most spectacular bombardment ever witnessed. Here on Earth, impact craters are quickly erased by the weather and erosion. But Arizona's meteor crater survives after a collision 50,000 years ago that left a hole almost a mile wide. According to one theory, the dinosaurs were killed off by a huge meteor 65 million years ago. It might have stirred up a worldwide cloud of dust or unleashed poisonous chemicals, wiping out 3/4 of all living species. In 1908, an asteroid exploded over Siberia, leveling almost 800 square miles of forest. In 1991, a double asteroid 4 miles across came within 2 million miles of Earth. These radar images revealed its unusual shape. While the odds may be very small, a direct hit on a major city could leave millions dead and cause unimaginable destruction. Scientists believe a catastrophe might be averted by changing the course of approaching asteroids with nuclear bombs. Venus is our sister planet, about the same size as the Earth, with almost the same gravity. But it lies 25% closer to the Sun. The difference is just enough to make Earth a cradle of life and Venus a living hell. On the infant Earth, volcanic eruptions reign supreme, spewing carbon dioxide and water vapor into the air. The water fell as rain, forming the life-giving oceans. Most of the carbon dioxide dissolved into the oceans and combined with rocks. Algae, the first simple life, gave out oxygen, helping to create the atmosphere that we breathe today. On Venus, volcanoes also poured out carbon dioxide and water vapor. And there's growing evidence that Venus once had shallow oceans, perhaps long enough for simple sea life to develop. But the sun gradually brightened and Venus got hotter. 3 billion years ago, the water had all boiled away into space. The carbon dioxide was left behind as a thick, heavy atmosphere with a crushing surface pressure 90 times greater than Earth. Russian spacecraft have landed on Venus, surviving for only a few minutes, long enough to send back close-up pictures of the rocky surface. Unlike Earth, the face of Venus is forever hidden by clouds. But the Magellan spacecraft has pierced this mysterious veil with radar, revealing a dramatic volcanic landscape with low plains surrounded by highlands. At the Jet Propulsion Laboratory, a computer has transformed the radar images into a soaring journey over the surface of Venus. We saw lava flows and towering volcanic mountains up to 7 miles high. This one, Sif Mons, looms a mile above the surface. We found lava domes unlike any in the solar system, shaped like pancakes. They rise up to half a mile high and average 15 miles across. They may be composed of sticky lava. We found unique circular volcanic vents called corona. Artemis is the largest, as big as the western United States. Artemis has a spectacular canyon so beautiful, it would be a top tourist attraction on Earth. We saw strange volcanic features like spiders with radiating cracks. And an unexplained mystery, lava flow channels up to 4,000 miles long. No one knows how they could flow that far without cooling. The planet is riddled with fractures, cracks, and faults, evidence of past earthquake activity on this tortured landscape. We travel over a large fault valley 600 miles long, formed by an ancient upheaval of the crust. Next, we skim the summit of the towering 2-mile-high volcano Gula Mons, surrounded by lava flows. Do volcanic eruptions still take place on Venus today? Magellan did not answer that question, but we did make a startling discovery. The surface of Venus is relatively young. A huge planet-wide volcanic outburst might have completely repaved the surface around 500 million years ago. Or instead, smaller volcanic flows may erupt every few million years. Finally, we soar over the rugged highland area known as Alpha Regio. Its tortured surface is composed of mountains, valleys, lava flows, and faults. This is one of the most cracked, squeezed, and stretched landscapes anywhere on Venus. What kind of forces created these awesome sights? And are they still at work today? Magellan has shown us that volcanic activity was a major tool in shaping the surface. But many questions remain unanswered, and years of study are ahead as scientists examine the wealth of data from Magellan and try to unlock the secrets of Venus. In ultraviolet light, we see fierce jet stream winds, pushing clouds around the planet every 4 days. Like Earth, Venus is a heat engine powered by the sun. By studying these simple weather patterns, we may gain new insight into the complex weather on Earth, as the oceans, the land, and the atmosphere transfer water and energy back and forth in a never-ending dance. Venus has also taught us to appreciate the delicate balance of nature that makes life possible on our planet. On the surface of Venus, it's a scorching 900 degrees. With its thick clouds and heavy atmosphere of carbon dioxide, Venus traps the sun's heat in a runaway greenhouse effect. Here on Earth, our industrial society is pouring carbon dioxide into the air. Some scientists fear we're creating our own greenhouse effect on a smaller scale. A rise of only a few degrees in the Earth's average temperature might trigger disastrous changes in our climate. In 1968, the Apollo 8 astronauts were the first to see our tiny planet floating in space. We realized that all of us are riding together on a fragile spaceship called Earth, and its future is in our hands.
The vast loneliness up here on the moon is awe-inspiring, and it makes you realize just what you have back there on Earth. The Earth from here is a grand oasis in the big vastness of space.
Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
In 1969 came man's greatest adventure. For the first time, we journeyed to the surface of another world.
Houston, Tranquility Base here. The Eagle has landed. That's one small step for man, one giant leap for mankind. This has got to be one of the most proud moments of my life, I guarantee you.
Between 1969 and 1972, 12 astronauts explored the surface of the moon as the world shared in this triumph of the human spirit.
Man, I'll tell you, Indy's never seen a driver like this. Okay, when he hits the craters and starts bouncing, it's when he gets his rooster tail.
I can't believe we came over those mountains. We did. It's just a beautiful little valley.
Wow, what a place. What a view, isn't it, John?
It's absolutely unreal.
Look at the size of that rock. The closer I get to it, the bigger it is.
There is orange soil. Light gray material on either side. Oh, man, that's incredible.
Thanks to the Apollo astronauts, we know more about the moon than any body in space, beyond our own. But a puzzling mystery remains. Why is Earth the only inner planet with a large moon? And where did it come from? Shortly after the birth of the solar system, a planet the size of Mars might have collided with the Earth, throwing off material that reformed into the moon. A heavy bombardment of meteors rained down on the early moon, leaving craters of all sizes. Then volcanic lava flows poured across the surface, creating lowlands or maria, visible from Earth as smooth, dark areas. The rest of the moon is composed of rugged highlands. $3 billion years ago, the moon became a dead world. Today, only meteor strikes disturb its surface, leaving a dusty powder and occasionally craters. The Apollo astronauts have given us a fascinating look at the first 1.5 billion years of the solar system, a period that has been erased from the records of our own active Earth. But more importantly, Project Apollo has made us all citizens of the universe. This message from the last man on the moon.
I'd like to just let what I believe history will record, that America's challenge of today has forged man's destiny of tomorrow.
8, 7, main engines start. Booster ignition. Lift off.
Here at NASA's Space Camp, the next generation is looking ahead to our future in space. Will they or their children live and work on another world? We may one day return to the moon and set up a permanent scientific base. The Apollo astronauts found aluminum, magnesium, and other metals that might be mined and used for construction. If frozen water is discovered on the moon, a lunar base would be far more practical. But others are aiming their sights on the red planet, Mars. For 200 years, we looked at this mysterious fuzzy ball and wondered at its secrets. Did life exist on our neighbor in space? At the turn of the century, Percival Lowell believed he saw canals built by a dying Martian civilization in a desperate attempt to water its crops on a world growing drier and drier. In the early 60s, some astronomers still believed that seasonal changes in color were caused by Martian vegetation. Today, we know those changes are triggered by giant dust storms. Our robot explorers have revealed the true Mars, a barren planet filled with dry, dusty deserts, cratered plains, lava flows, and giant volcanoes. The largest volcano, Olympus Mons, towers 15 miles above the Martian landscape, 2.5 times higher than Mount Everest. Its base is 335 miles across. At the top is an immense caldera of overlapping volcanic outlets, almost 50 miles wide. We don't know if the volcanoes of Mars are still active today. Here is one of our most astonishing discoveries, evidence that water once flowed on Mars. We saw elaborate dry riverbeds and channels, some of them hundreds of miles long. Where did these channels come from? Today, liquid water cannot exist on this cold planet that has almost no atmosphere. Volcanic eruptions might have melted the frozen surface just long enough for water to flow briefly. Or was the early Mars much warmer with a thicker atmosphere, oceans, and even simple life? Some of the river channels could be the result of flash floods from Martian lakes. But if Mars once resembled Earth, those days are gone forever. With its lower gravity and its distance from the sun, Mars has evolved into a cold, dry world, devoid of life. This may be all that's left of a dried-up lake, photographed from Martian orbit. Despite its hostile conditions, Mars bears the closest resemblance to Earth of any body in the solar system. It's half the size of our planet, but with no oceans, it has almost as much land. A day on Mars is about the same length as one of ours. A Martian year is 2 Earth years long. And there are 4 seasons. The polar caps shrink in summer and grow larger in winter. Mars also has weather. An ice haze or fog often develops in canyons and valleys in the early morning hours. There are wispy storms of water and ice, winds, and fierce dust storms that can blanket the entire planet. The space age has only increased our fascination with Mars, and sometime in the 21st century, a human expedition will almost certainly take place. The outbound journey will last 6 to 9 months in a ship that might be powered by nuclear engines. In the 1960s, nuclear rocket engines were tested in the Nevada desert. They may offer the most efficient and quickest route to Mars. Once the ship is in Martian orbit, shuttlecraft will take the explorers down to the surface. What will we find on man's first journey to the Red Planet? In 1976, 2 Viking spacecraft gave us a glimpse into the future.
ACS is close to vertical.
Nav is green for touchdown.
ACS is green, 1.5 degrees per second max, 0.2 Gs.
Touchdown win. Fantastic. 16 kilobits confirmed.
The Vikings showed us a rugged landscape of rocks and sand dunes, tinted red by iron oxides. To walk unprotected on Mars would be to perish instantly. The atmosphere of carbon dioxide is 100 times thinner than the air we breathe, and the average warm day is 20 below zero. The Viking landers scooped up soil and analyzed it in their built-in laboratories. They found no evidence of life. Our first settlers will need rugged shelters to protect themselves from the intense solar radiation and gigantic dust storms pushed by 300-mile-an-hour winds. Is a permanent base possible on this hostile, far-off world? The frozen water of Mars is a great resource. The North Pole has large volumes of ice and an amazing series of ice cliffs with layered terraces. This strange sight might be the result of changes in the Martian climate over millions of years. Elsewhere, there may be plenty of ice buried underground, just below the rocky surface. If we can reclaim the water, we can drink it. We can use it to grow crops in greenhouses. We can split it into hydrogen for fuel and oxygen to breathe. For 2 years, 8 scientists lived inside a miniature version of Earth called Biosphere 2. They grew their own food, recycling their water, air, and waste. Biosphere 2 showed that we can live away from our home planet with ingenuity, discipline, and energy from the sun. Valley Marineris, the Grand Canyon of Mars, was created by an ancient split in the crust. It's as long as the entire United States, 150 miles across and up to 4 miles deep. Our Martian explorers will indeed find wonders beyond imagination. Through the magic of supercomputers, our still pictures from Martian orbit have been transformed into a spectacular preview of things to come. It is sunset in the faint, dusty atmosphere of Mars. But for mankind, this is the dawn of a new age. Our journey takes us outward, beyond Mars, to the asteroid belt. Thousands of rocky pieces left over from the creation of the solar system. The spacecraft Galileo has shown us 2 of these asteroids. Ida is a chunk of rock and minerals 30 miles long, with its own tiny moon. 500 million miles from the sun, we enter the realm of the giants. Jupiter is large enough to hold 1,000 Earths. Its outer layer is a ball of gas, mostly hydrogen, with some helium. If Jupiter was 80 times more massive, it would have become a star. This is a planet in motion, rotating once every 10 hours. It's ringed by alternating bands of jet stream winds, traveling in opposite directions. Eddies are stirred up between the opposing wind currents in a swirl of abstract art. Jupiter is colored in reds, browns, whites, and blues from clouds of frozen ammonia and ice at different altitudes. The Great Red Spot is a giant hurricane twice the size of Earth. It was first seen nearly 300 years ago. It continues to rage on, rotating once every 6 days. Deep inside Jupiter, the temperature and pressure gradually rise until hydrogen becomes a liquid, and finally a liquid metal. At the very center is a small rocky core. This huge rotating mass generates an immense magnetic field up to 8 million miles across that is constantly bombarded by the solar wind. This mighty colossus is circled by 4 major moons. Each is a unique world of its own. On the right, Europa. On the left, Io, both about the same size as our own moon. Through the remarkable eyes of the 2 Voyager spacecraft, this amazing family of worlds has been revealed to us for the first time. Io, the closest moon to Jupiter, is racked by volcanic eruptions. It's heated by a gravitational tug-of-war between Jupiter and 2 other moons, squeezing and stretching this tortured world back and forth. Io gets so hot that its inside has partially melted, triggering constant sulfur eruptions. 9 eruptions were underway as the Voyagers went by. As the sulfur rains back down, the surface is continuously renewing itself. Here is a kaleidoscope of color, of frozen lakes of sulfur and volcanic outlets. Io is caught in a storm of radiation from Jupiter's magnetic field that strips a ton of material every second from the surface of this battered moon. The result is a huge cloud of charged particles that takes the shape of a giant donut as Io circles Jupiter. Europa resembles a cracked eggshell with a smooth surface of ice crisscrossed by giant streaks. These might be cracks in the ice that are still being formed today as Jupiter's gravity heats Europa. And beneath the frozen surface, it might be warm enough for an ocean of liquid water. Could such an ocean contain simple life? We can only guess at the true nature of this mysterious world. Ganymede is the largest moon in the solar system, slightly bigger than the planet Mercury. Patterns of ridges and grooves crisscross the entire surface. They were apparently created as this icy world began to cool billions of years ago. On this jumbled terrain, there are many separate blocks that slipped past each other in those ancient times. Their boundaries resemble large earthquake faults. Callisto is the outermost of Jupiter's 4 large moons. It has a smooth, icy surface that's completely covered with shallow craters. This is the most heavily cratered body ever discovered. Callisto has remained this way for 4 billion years, virtually frozen in time. As we leave mighty Jupiter, we look back at its ring, glowing in the sunlight, just one of the many discoveries by the amazing Voyager spacecraft. Like a modern Christopher Columbus, the Voyagers had revealed 4 new worlds and a giant planet. But a lot more was yet to come. A year and a half later, the Voyagers reached Saturn, 1 billion miles from the Sun. With its magnificent rings and its pearl necklace of moons, Saturn is the most beautiful object in the solar system. The rings are frozen chunks of ice mixed with dust. They range in size from microscopic grains to icebergs dozens of feet across. This false color image shows the difference in composition from one ring to the next. From Earth, we can see half a dozen major rings, but Voyager discovered thousands of tiny ringlets. The rings are shaped by gravity from Saturn and its moons. This faint ring is composed of delicate braided strands. Two small shepherding satellites hold the ring together, one on the outside, the other on the inside. Voyager discovered dark spokes that move quickly around the rings, only to break up and vanish a few hours later. They may be dust particles caught up in Saturn's rotating magnetic field. Saturn is our second largest planet. Like Jupiter, it's a rotating ball of gas and liquid. Saturn also has bands of jet stream winds 4 times as fast as Jupiter's. And there are oval-shaped storms, smaller versions of Jupiter's Great Red Spot. In 1990, the Space Telescope photographed a gigantic storm spread around Saturn's midsection. Storms this big arise on Saturn about once every 30 years. They may be caused by the changing seasons on this distant world. Titan, the second largest moon in the solar system, is truly unique. It's our only moon with a sizable atmosphere. Shown here in blue, it's a heavy blanket of nitrogen, 50% thicker than our own air. Sunlight creates a smog-like haze that completely hides the surface of Titan. We can only guess what lies beneath. The sky may be filled with methane clouds and a drizzling rain. Below it, a frozen surface dotted with hydrocarbon lakes. Titan's atmosphere is a sample from the distant past. It may teach us more about Earth's primitive atmosphere as it existed 4 billion years ago. Saturn's other moons are much smaller, all of them frozen balls of ice with some rock. The Voyagers gave us a grandstand seat. Mimas has a huge crater from an ancient collision that almost tore this tiny world apart. Tethys has a much larger crater. Dione is also heavily cratered. Rhea has bright streaks of ice across its face. Iapetus is the two-tone moon, one half extremely dark, the other half bright and icy. Yet another unexplained mystery. Enceladus looks like a combination of other moons, with separate areas of craters, lines, grooves, blocks, and twists. Evidence of many changes over billions of years. And we found dozens of tiny satellites orbiting the outer worlds. Hyperion is only 200 miles across. As they sped away, the Voyagers looked back in a final farewell to majestic Saturn. But the mission was not yet over. Every 179 years, there's a rare alignment of the outer planets that makes a grand tour possible. Voyager could visit all 4 giant worlds by using the gravity of each one as a slingshot. As Voyager 1 headed out of the solar system, Voyager 2 charted a new course for Uranus and Neptune. Uranus is our only planet that's tilted on its side. It was either formed that way or knocked over by an ancient collision. 4 times wider than the Earth, Uranus is surrounded by a faint band of rings. To the human eye, Uranus is a hazy ball with no visible features. But computer processing has revealed atmospheric bands of wind. Seen from the South Pole, they form an eerie eyeball in space. With this 8-frame movie, we discover that Uranus rotates every 17 hours. Our most fascinating discoveries at Uranus were its 5 major moons: Umbriel, Titania, Miranda, Ariel, and Oberon. These worlds of rock and ice range in size from several hundred miles to 1,000 miles across. Ariel is crisscrossed by smooth valleys. In the ancient past, cracks developed as Ariel cooled. Then, melting ice flowed across the surface like lava, filling in the valley floors. Miranda is one of the most bizarre moons ever seen, a patchwork of craters, grooves, ridges, valleys, and a unique object that looks like a chevron. Miranda may have been shattered at least 5 times by ancient collisions, the pieces reforming into a strange new pattern after every breakup. With computer processing, the Voyager pictures take us on a journey of discovery across the surface of this amazing moon. "12 years after it began, the historic odyssey of Voyager 2 came to an end at Neptune, 3 billion miles from the Sun. Uranus and Neptune both have heavy cores of rock and hot liquid, topped by atmospheres that are rich in hydrogen. Neptune's deep blue color is caused by methane in the atmosphere. These bright streaks are clouds of frozen methane. And Neptune has its own version of Jupiter's Great Red Spot, a giant rotating storm called the Great Dark Spot. On Neptune, we have found the strongest winds of any planet, up to 1,500 miles an hour. Neptune's large moon Triton is probably a captured planet, because it orbits in the opposite direction to Neptune's rotation. This super cold world of ice is covered with an amazing assortment of strange terrains. As we scan the surface, we see the result of Triton's remarkable evolution, first on its own for several billion years, and then under the domination of mighty Neptune for several billion years more. And Voyager's final surprise, dark smudges visible in the lower part of the picture, may be evidence of nitrogen ice volcanoes, several of them erupting as the spacecraft went by. On the left, the source of the eruption. A long cloud trail streams off to the right as nitrogen gas and dark dust particles are thrown several miles into space. Pluto was not on Voyager's grand tour, but we believe it's very similar to Triton. This is an artist's view of Pluto. In the sky, its moon, Charon. It was a dramatic sight as Voyager 2 looked back at giant Neptune and its fascinating moon Triton, the final outpost of our solar system. As the Voyagers sail on into deep space, they leave behind an amazing legacy. They have truly opened our eyes to the wonders of the outer solar system, but they have also raised far more new questions than the old ones they have answered. Beyond the orbit of Neptune, we believe there's a swarm of 1 trillion icy chunks left over from the creation of the solar system. Every so often, one of these particles plunges inward to a close orbit around the Sun. As it greets the solar furnace, it's transformed into an object of spectacular beauty, with a glowing head and a streaming tail. We call it a comet. In the Middle Ages, comets were greeted as mystical visitors from the heavens. Often, they were seen as evil omens, evoking fear and terror. Scientist Edmund Halley was the first to discover that comets orbit the Sun. Just as he predicted, the great comet he witnessed returned 76 years later in 1758. 1910 brought a close encounter. Many people feared that life would be snuffed out by poison gas as the Earth passed through the tail of Halley's comet. The fears proved unfounded, and the sight of the comet stretching 1/4 of the way across the sky was the event of a lifetime. In 1986, the Earth was in a poor position to view Halley's comet. It took a special effort to see it, but those who journeyed far from city lights caught a glimpse of the most famous comet in history. To the human eye, it was far less than spectacular. But this would prove to be Halley's most important visit ever, because this time it was met by 5 spacecraft from Western Europe, Japan, and the Soviet Union. The European Space Agency's Giotto penetrated inside the comet's glowing head to photograph the hidden nucleus. For the first time, this dirty snowball was revealed to us, a lumpy, potato-shaped object 9 miles long with a black chemical coating. Jets of gas stream off its surface as the Sun heats this primitive object more than 4 billion years old. With the dawn of the space age, we have truly seen our solar system for the first time. We have seen amazing worlds, each in their own way, molded by nature's tools. Heat, gravity, and the bombardments of the early solar system. We have seen how each unique body has evolved according to its composition, size, and distance from the Sun. And these alien worlds have given us new insight into the most unusual planet of all, circling the Sun in this narrow zone of life. But our quest for knowledge goes on. New American spacecraft will orbit Mars and land on its surface. A 2-foot-long rover will explore the Martian terrain. In 1999, a 4.5-foot-long Russian rover will journey across the Martian landscape, navigating over rocks and sand dunes. The same mission will include a French balloon that can float over the surface, taking panoramic pictures of the view below. In December 1995, Galileo begins a 2-year mission to photograph the moons of Jupiter in finer detail than ever before, also dropping a probe into Jupiter's atmosphere. In 2004, Cassini will orbit Saturn, studying its moons and releasing a European probe into Titan's atmosphere. And we may get our first close-up look at Pluto early in the 21st century. In 5 billion years, the sun will begin its final death throes, growing to an angry red giant as it runs out of hydrogen fuel. Long before then, life on Earth will cease to exist as the sun grows steadily hotter. The search has already begun for worlds around other stars. Here, we may be witnessing the birth of a new solar system, a flat disk surrounding the star Beta Pictoris. It offers hope that planets are common elsewhere. So one day, in the far distant future, mankind may embark on a final journey to the stars, to a new planet Earth, with only memories of the magnificent solar system we once called home.